All right, we are in Chapter 2, Section 5, called Solving Equations Involving Absolute Value. So as always, I start the videos off with this little kind of tutorial for Alex. So this is the screen you will see as a student when you log in, with the exception of a couple of little features. So first, you will see a due date here in front of attempts. I don't see that on my teacher preview. On attempts, it shows me this is my first attempt of unlimited attempts. I can come in and do this assignment as many times as I would like. That's what unlimited attempts means. This one has 5 questions on it, so your assignments will have anywhere from 1 to 10 questions. Grading policy is always the best score, meaning your best attempt is the one you get to keep. Partial credit is enabled, and that means if I answer 1 of 5 questions, I get credit for the 1 question. This is a note that is about submitting your work. So when I click Start here, on your screen, so again, this is only on the student screen. You won't see it on here, but this is where it is. It's going to be down here in the bottom right corner. You're going to see Submit Assignment. You always want to click Submit Assignment. Whether or not you've answered any questions, only 1 question. If you've answered all the questions, doesn't matter where you are within the assignment. Once you start, you click that button. Number 1, it shows us that you started it, how many you did, what your percentage was, and it also will not lock you out of other assignments. If you just leave this, if you close the window, or if you hit the little home menu button and you leave and go back to home, it's going to let you leave, but it's going to lock every other assignment. So no other homework, tests, quizzes, topics, everything will be locked until you come back in and click that submit button. So just keep that in mind. All right, on the right side here, you always see these 3 buttons. You may also see a calculator here, and that just pops up from time to time depending on whether Alex opens it. Explanation is an explanation of literally the problem we're looking at right here. So you're going to lose this question attempt. You can actually see the solution to this question. So it's going to give you the solution and the answer. It's not going to then let you come in here and type it. So it's going to put an X on here, and you're going to have to submit the assignment and come back in and try another one, okay? You may also be able to click try another at the bottom. I can't remember if that pops up when you do explanation. Example gives you an example quite literally of this type of problem. So it's also a very nice little resource here. So it'll give you an example very similar to what we're looking at. Here's the explanation of how to do it, and here's how you type in your answer. If you want another one, you just click on example again, and it'll give you a brand new example. You can also message your teacher directly from this page, and it'll attach this question to your message so we know exactly where to help you. All right, let's go ahead and get started on this homework assignment. So we're going to be dealing with absolute value. So first, we're just going to introduce the idea of absolute value for the first couple of questions here. So if we look at a number line, because this is the way I like to do this, absolute value is a distance from a midpoint. So this is the kind of the basic definition of absolute value. And distance can't be positive or negative. It's just a movement. So when we're looking at here, we have our midpoint. And on simple ones, it's going to be 0. But it's not always going to be 0 when we kind of get toward the end here. But for very simple ones, 0 will be our midpoint. And we can move to the right. Well, that's a positive movement. I'm going toward the positives. Or I can move toward the left, and that's toward the negative. So it's a negative movement. So it's just the way we do that. So right is positive, left is negative. Those are associating. But really, we're just saying we're moving to the right, we're moving to the left. The way we represent that in an equation is with positives and negatives. Okay? But keep in mind, it's a distance that we're moving. So if I want to know all the numbers whose absolute value is 7, I'm asking what numbers move 7 spaces from my midpoint. If my midpoint is 0, because this is a very simple one, so on the simple ones, your midpoint will be 0. I'm going to move 7 spaces to the right, that's positive 7, and I'm going to move 7 spaces to the left, which is negative 7. So both of those will get me an absolute value of 7. So I just type in -7, comma 7, and it told us if there's more than one to separate them with a comma. So these are my two possibilities to get an absolute value of 7, a distance of 7. I do want to bring up the fact, since none is an option here, I haven't seen it come up, but it very well could. You'd only have none if it said, what is the absolute value of a negative number? Well, that means we're not doing a distance anymore, because a distance can't be negative. So remember, this is asking, find the numbers whose distance, absolute value, is 7. Well, if it was a -7, that wouldn't work. You wouldn't have a -7 distance. I'm moving either right or left. So as soon as you see negative, that would be the none. All right, let's keep moving here. So for this next one, it's the same idea, but now they're going to ask us with symbols instead of words. So we have solve for u, the absolute value of u equals 7. So we want to know, what would I plug in here to have a distance, a movement of 7? So this is actually exactly the same as the last one, just with symbols. I have my midpoint, which again, on these very simple ones where we just have a variable here, we're moving from 0. So if I want to move 7 to the right, well, that would be +7. If I want to move 7 to the left, that would be -7. So in this case, I actually have the same answer for both my first and second questions. This is actually the first time I've seen this one pop up this way. So all different kinds of combinations of numbers here, but the main idea is you're looking at, okay, well, how do I move 7 units? If I move 7 units right, then I land on 7. If I move 7 units left, I land on -7. Alrighty. So I'm going to undo a few things here. Okay, so now we're getting a little bit more complicated, because now we don't have just the absolute value of u, it's the absolute value of u minus 17 equals -8. So once we start getting to some of these multi-steps, or more than one step, just more than, what's my distance, I have to have the absolute value by itself first. So you have to isolate the absolute value, all right? So what we want to do, just the same thing that we would do if we were solving an equation. So we kind of want to solve for the absolute value. That's another way we can look at that. So I want to take this -17. I don't want anything on the same side as that absolute value. I don't want to be adding something on the outside, subtracting. I don't want to see a multiplication in front of here. I don't want to see division below. Anything that's happening to the absolute value needs to be moved over to the other side. So plus 17, because that's how I'm going to undo that. Now I have the absolute value of u equals 17 minus 17 cancels. And now I have -8, +17. I'm going to subtract. And it'll get me 9. And since I have positives instead of negatives, or I have more positives and less negatives. So it's going to be a +9. All right, so now this looks exactly like our last problem with just a different number here. So what can I plug into here to get an absolute value? Our distance of 9. So if I move to the right and I want 9 movements, well, that's going to land me right on 9. If I want to do the same thing on the left, that's going to land me right on -9. All right, so I have -9 and 9. Check. All right. So the next one, we're going to get away from the idea that our midpoint is 0. So remember, that's only on very, very simple ones where we have a single variable. Well, when we have an equation like what we're looking at here, this is not going to be the midpoint of 0 anymore. Now we're moving away from that point. It's going to be somewhere else. So now our midpoint, and we can just simply kind of simplify that and say that is our midpoint, 3y minus 12. So with this one, I'm going to have case 1, which is positive. So we're going to move to the right 6 units. Okay? So this is case number 1, where I have my midpoint equaling my distance. Case number 2 is going to be my negative, or my left movement. So I'm going to move to the left 6 units. So I'm going to have my midpoint equaling -6. So now I just have to solve these two, just like I would any other equations. So I'm going to go, what's being added or subtracted to the variable? Well, 12 is being subtracted, so I'm going to add 12 to both sides. 3y, 12 minus 12 cancels, and 6 plus 12 is 18. So now I'm going to divide by 3 because I'm multiplying by 3. Y equals 6 because 18 divided by 3 is 6. So this should be my biggest one, my maximum, when I'm looking at case 1 and case 2. Case 1 should always give me my biggest number. Case 2 should always give me my smaller number, or the smaller side of the graph here. And if we kind of think about that, if case 1, if I'm moving to the right, that should be bigger than if I'm moving to the left, right? So hopefully we can kind of make that connection with the first case should be bigger than the second case. All right, so we're going to do exactly the same steps, actually, because we're subtracting 12 still, but it's going to react a little differently on the right side now. We still have 3y come down. 12 minus 12 still cancels. But now we have negative 6 plus 12. It's not 6 plus 12 anymore. It's negative 6 plus 12. So I need to subtract them. I have more positives than negatives, so it's going to be a positive 6. Divide by 3. Divide by 3. So I have y equals 6 divided by 3 is 2. So 6 and 2. Those are my two pieces. So I'm just going to type these guys in. Whoops, comma 2. And ta-da! So we want to make sure that we set up our cases. It's the same idea as these kind of more simple ones that we had here. Well, this is a little bit more simple. You know, same idea here. I'm going to move positive 7. I'm going to move negative 7, or right 7 and left 7. Well, I'm doing the same thing on these ones, but now I have to take into account that it's quite a bit. There's more to the midpoint than just starting at 0. We're going to start from a different midpoint now. All right, so let's go ahead and continue to number 5. Oh goodness, it's too small. Taking too long to erase there. Okay, and all that junk. Okay, so we're starting with our equation here. W plus 6 equals negative 30. So remember, I need to isolate the absolute value before I start doing the movements. Okay, so there's something being multiplied out here. I don't want that. I'm going to divide both sides by negative 3, because negative 3 divided by negative 3 cancels, and I just have the absolute value of W plus 6. And that's going to equal negative 30 divided by 3, which is 10. And again, we don't want it to equal a negative number. That's a big no-no. But we need to simplify this first before we just decide that's no solution, okay? So now I can set up case 1, which is my positive. So my midpoint is W plus 6, and I'm going to move to the right 10 units. Case number 2, which is my negative movement or my left movement, here's my midpoint, and I'm going to move negative 10, or to the left 10. All right, so now I have to just solve these guys. So I'm adding 6. I'm going to subtract 6 from both sides. So I get W equals, those guys cancel, 4. So here's my first. This should be my maximum. And then I'm going to subtract 6 here. And I'm going to get W, these guys cancel, negative 10 minus 6. Be careful in this one. I'm at negative 10. And I'm taking 6 more away. So I'm going to go combining them. I'm going to add them together, and I'm going to leave the negative sign because it's going more negative there. So I have 4, and I have negative 16. All right, let's go ahead and check that guy, and we are good to go. So that was section 5, and I will see you in section 6.